Hey, thanks for clicking on my video. If this video helps you, please consider liking this video and subscribing to my channel. It is greatly appreciated and it really helps. Let's get to the video. Hello everyone, in this video we're going to talk about how we can find reference angles. So remember, we've talked about theta, the Greek letter, being what we use for our angle in standard position. So remember, standard position, we've got our terminal side that is starting on the x-axis, right in between quadrant 1 and 4, and it is going up counterclockwise to form our angle theta. So now our reference angle for theta, we're going to use theta prime. It is an acute angle that's formed by the terminal side of theta and the x-axis. So if we think about this, the angle itself, theta, is going to be the same as theta prime if the angle is in quadrant number 1. Because angles in quadrant 1, those are still acute angles. So now we just need to identify, okay, what would our reference angle be for quadrants 2, 3, and 4, or how would we find that? And so that's what we see in this diagram right here. So let's look at quadrant 2 on the left. So we know that as our angle opens, it ends up in quadrant 2, so it's somewhere between 90 and 180, or pi over 2 and pi if we're talking in radians. So to find our angle, our reference angle, theta prime, we have this little area right here, that's our acute angle. So if we think about how we would find that measure, well, we know that in degrees, 180 would be where we are there on the x-axis, that angle. So 180 minus theta, that's going to give us our reference angle theta prime. And so now for radians, all the way 180 degrees would be pi radians. So we would do pi minus theta to get our theta prime, or our reference angle. For quadrant 3, we would do the opposite of that, because now we are past 180 degrees. So we're going to take our angle measure in standard position theta, subtract 180, and that's going to give us our reference angle theta prime. And also in terms of radians, we would take our angle measure in radians and subtract pi, and that would give us our reference angle in radians. And then lastly, for quadrant 4, now if we go all the way around, that would be 360 degrees. So now we can do 360 degrees minus theta to get our reference angle theta prime. And it would be 2 pi radians, so same scenario, we could do 2 pi minus theta to get theta prime, our reference angle, okay? So we're going to look at 6 examples, 3 in degrees and 3 in radians. So we'll start with number 1, it is negative 220 degrees. So what the negative means there is that we are just now taking our terminal side of our standard position angle, and now instead of going counterclockwise, we are going clockwise. So if we go negative 220, we need to think about a coterminal angle that would be as if we went counterclockwise for our angle there. So negative 180 would get us to our x-axis over here between quadrants 2 and 3. And so now we're going to go 40 more degrees up from that. So a coterminal angle here would be 140 degrees. Another way of thinking about that is we could just add 360 to negative 220, and we're going to get negative 140. Or excuse me, positive 140. Okay, so now we know that that is in quadrant number 2. So quadrant 2 says we need to take 180 minus theta. So this would be theta is equal to. So we need to do 180 minus 140 to get 40 degrees. And this would be theta prime. So our reference angle for number 1 would be 40 degrees. All right, for number 2, we have 250 degrees. So 250, as we're going around standard position, going counterclockwise, we know it's going to be in quadrant 3, because that is 20 degrees less than 270, which would be on our y-axis between 3 and 4. So now we know that we need to take our 250 degrees, or our theta. So in this case, theta is equal to 250. And we're going to minus, or we're going to subtract 180 degrees to get our reference angle of 70 degrees. So our reference angle for number 2, theta prime, would be 70 degrees. And number 3, 315. Well, 315 we know would be all the way around, almost back a full circle. So this would be in quadrant number 4. So in this case, we're going to take 360 minus 315, because 315 would be equal to theta. And this is going to give us 45 degrees for theta prime. Okay. All right, now let's look at 3 examples where we have our measures in radians. So for number 4, we have 7 pi over 6. Well, if we think about 7 pi over 6, well, 6 pi over 6 would be pi, so that would be right at the x-axis between quadrant 2 and quadrant 3. So it's a little bit past that. So we are in quadrant number 3, 7 pi over 6. So quadrant 3 tells us to take our degree measure, or excuse me, our angle measure. In this case, it's radians. So 7 pi over 6 and subtract pi. Well, pi and with a denominator of 6 would be 6 pi over 6. So 7 minus 6, we're going to get pi over 6 for theta prime. So our reference angle for 7 pi over 6 would be pi over 6. And number 5, we have 15 pi over 16, so not quite to 1 pi. That would be 16 pi over 16. So this tells me this is going to be in quadrant number 2. So in this case, we're going to take pi and we're going to subtract 15 pi over 16. And that's just going to give us pi over 16 as our reference angle theta prime. And lastly, number 6, 7 pi over 4. So 7 pi over 4, if we think about 270 degrees, which would be on our y-axis between quadrants 3 and 4, that's 3 pi over 2. So if we multiply that, that would actually be 6 pi over 4. So it's a little bit more, so we know we're in quadrant number 4. So quadrant 4 tells us to do 2 pi minus 7 pi over 4. So 2 pi with a denominator of 4 would be 8 pi over 4. So this is going to reduce to pi over 4 as our reference angle theta prime. And that is how you can find reference angles.